Hello, grade 12. This lesson in page 114, Newton's second law in 2 dimensions. Exercise 6C, page 119. Your homework is 1, 2, 3, 4, and the project is number 5. And I'm gonna take 2 examples, example 6.4, page 115, and 6.6. Let's start. Before we start, this lesson is talking about when an object is moving with a constant acceleration. Now you are going to use Newton's second law in addition to resolving forces. Okay, let's see an example 6.4. Go to the book and follow me from the book. Example 6.4 says that Anna is sledging. Her sister gives her a push at the top of a smooth, straight, 15-degree slope, and let's go when she is moving at 2 meters per second. She continues to slide for 5 seconds before using her feet to produce a braking force of 95 Newton parallel to the slope. This brings her to rest. Anna and her sledge have a mass of 30 kilograms. How far does she travel all together? Again, the story of Anna. This is the sledge. She's sliding. Her sister were here. She gives her a push to slide down. This slope is 15 degrees to the horizontal. The weight of the Anna and the sledge is 30 kilograms, means 300 Newton. And it moves with an acceleration. She started moving at 2 meters per second for 5 seconds. And she applied her feet to make a brake. So she applied a force of 95 Newton to stop herself by her feet. And then she came to a rest at the end. We need to know how far does she travel all together before the braking and after the braking. So we'll start saying that we need to see the forces acting on the sledge. It is the force of the weight, which is 300, and the reaction force, which is perpendicular to the slope. Okay, this force can be resolved into 2 forces. Since this angle is 15, so this angle from property of the shape will be 15 also, because this will be 75 and the sum of these 2 angles is 90, so this will be 15 also. Memorize this 15, so this will be 15. If you resolve this force 300 to be 300 cosine 15 and 300 sine 15 in these 2 directions, the direction of the slope and direction of perpendicular to the slope, we can say that F equals ma, Newton's second law. So the only force acting in this direction is the 300 sine 15. This equals ma, the mass, which is 30, times the acceleration 1, because she has 2 acceleration before braking and after braking. So I can get the acceleration now. It's 2.58 meters per second squared. Now I can use this acceleration with the given information, which are that she started moving at 2 meters per second for 5 seconds, to get the displacement, the distance. S equals ut plus half at squared. This is the equation of motion. Do you remember the equation of motions? S equals ut plus half at squared. By substituting here, you can get S, which is 42 meters. So she covered 42 meters before applying her feet. And what was the final velocity? V equal u plus at, another equation of motion. If you use u equal to 2, acceleration is 2.58 and t equals 5 seconds, so you can get that she ends up with 14.94 meter per second velocity. When braking with a force of 95, when she applied her feet, now she has a resistance force. Means this force is opposed by another force here, which you can say that it is R, for example. The resultant force is this force minus this force. This force will be 95. So I can say that F equals ma 300 sine 15 minus 95 equals ma 30 times a, this acceleration 2, which is the acceleration when she starts applying her feet until she came to rest. So I can get a2. It is a deceleration 0.5578. By using this deceleration, I can get and the speed, the final speed will be 0. The initial speed will be 14.94. Using this equation of motion, I can get the second displacement, which is 192 meters. So she moves with the first acceleration a distance which is 42.352, and with the second acceleration she moved a distance with 192.94. This is the sum of the two distances. So in this example I used Newton's second law. I used the equation of motion. I used also resolving forces. In example 6.6, this is page 118. A car of mass 1000 kilograms, including its driver, is being pushed along a horizontal road by 3 people, as indicated in the diagram. These are the 3 people: Dean, Kelly, and Emma. They are pushing this car in this direction. The car is moving in the direction of PQ. Calculate the total force exerted by the 3 people in the direction of PQ in this direction. So let's resolve these 2 forces. This is the force diagram. This is the car. We have the force of Dean, which is 270, this one, and the 200 Kelly. I resolved this force into 2 directions. This one, which is 200 cosine 15, and this one 200 sine 15. Also this force, which is Emma, 240, will be resolved into 2 forces. This one 240 cosine 25, 240 sine 25. Okay, the sum of these forces in this direction are in direction of PQ. R means the resultant force is, R here is the resultant force, is the three forces, which are 200 cosine 15, 270, 240 cosine 25. It will be 681 in this direction, this force. In the direction perpendicular to PQ, it will be this force and this force. One is against the other. What's the positive direction? The positive direction is this, up. You have 240 sine 25 minus 200 sine 15, which is 49.6 Newton. This number I and double I. In number triple I, explain briefly why the car does not move in the direction perpendicular to PQ. Why should it move in the direction of PQ? Because this force is higher than this force. So supposedly the car will move in this direction. But the car already moves in this direction. Why it is not moving in this direction? Why? Because the driver was holding the steering wheel tightly to prevent her from moving in this direction. And this came on the account of a friction force between the tires and the road, because there is a friction force between the tire and the road. And number IV, calculate the force of resistance to the car's movement in direction of PQ. Let's consider a force of resistance working against the car. This came from the friction, also of the tire and the weight. So I can say that the sum of these forces minus this force, FR means F resistance, equals MA. But before getting that, I have to get the acceleration of the movement. To find the acceleration of the car, apply this rule: V equal U plus ET. V is the initial velocity, V is the final velocity, U is the initial velocity, because he said that initially the car is stationary and 5 seconds later it has a speed of 2 meters. Means after pushing the car, it moves from rest until 2 meters per second velocity for 5 seconds. So when you use this information, it starts from rest and moves to 2 meters per second at 5 seconds. So I can get the acceleration of the car, which is 0.4 meters per second squared. I use this acceleration again when I say that this force works against this force. So I can say that this force minus this force equals ME. Means 681, the total force in the direction of PQ, minus FR, F resistance, equals ME 1000 times A, acceleration. And since the acceleration is 0.4, so I can get the F resistance, which is 281. Thank you.